This unit will be in a sense the first one to discuss something which directly is applicable as we can call engineering, and whatever we have studied till now as tricks, tools, techniques, methods, so those things will be now used to talk about which we will generally be calling as structures. That means they are in balance, everything is in balance, and the conditions of that balance which we will term as equilibrium technically. So that is the main topic of discussion under this unit. And when we say balance, for that, so let me say the technical term which we will be using is equilibrium. And when we say equilibrium, if we want to technically define it in a single sentence, we can say that if a system when I say, now we are quite familiar with, that means a body or a multiple of number of bodies connected with each other, and then being applied, many forces and couple moments are being applied on that body, and that whole thing we call as a system. And now that system, if can be represented as an equivalent wrench, so I'll say a force in some direction and a couple moment, I'll show it in the opposite direction for generality, but it need not be in opposite direction, it could be in the same direction. So this is a C and a F, so FR, CR. or better way, I'll represent that as say FW for wrench and CW for wrench. So the whole system of forces, if we can represent that as a single force and a couple moment in the same direction, and if everything, this CW also is equal to 0 and FR is equal to 0, then we call the system is in equilibrium. Now there is a catch here, not a catch in a sense, you have to be very careful about what forces we are talking about when we talk about these forces and couple moments, the blue ones. Here we are including all the forces and couple moments, whether they are externally applied on the system or they are getting produced by the reaction from the ground or the support to which they are connected to. Okay. For example, maybe this blue force which I call say F1 here could be coming from a ground support which may be a roller support. Okay, somewhere the ground is in contact and there is a normal force which is coming, a frictionless contact, and maybe this is that force, and maybe this couple moment is some sort of ground reaction, a couple moment reaction which is coming from some other point of contact to the ground. Now we are now considering everything in one view. Basically we should consider all the internal and external forces. Internal, when I say, I should not call internal, I should call reaction forces from the ground. So support reactions plus externally applied load, everything has been considered here, and then their equivalent force system or wrench, equivalent wrench, if it is 0. Or so that is one way to look at it, or the other way to look at that is okay, I'll just what I'll do is I'll draw another picture. So maybe, so it is the same body maybe, and now out of these forces, maybe this one was a reaction forces, F1 reaction, and maybe this also was say F2 reaction. But now these forces, perhaps F3 and maybe this one which I had shown. So this M or whatever. Now these were external, okay. For external I'll put say E over as a subscript. Now if I segregate these two like this, external and reaction forces, because external forces means which we know how much we are applying on the system, and the reaction forces are the forces which the ground generates by the mechanism of molecular interaction, they get generated, okay. Now so then another view is that if we consider only the reaction forces, so the wrench that is the C, shall I use the same color, maybe the C wrench due to external must be equal to the C wrench of the, what will I say, applied for to the reaction, okay. So negative of that. Similarly force wrench should be equal to negative of force of the wrench of the reaction forces. This is, that means this side, this part is the wrench which is the equivalent resultant or the simplest resultant coming from all the externally applied loads, and the other side, the right hand side, is the wrench or the simplest resultant which is coming out of all the reaction forces from the ground, the supports, and then they must cancel out each other. So then we will say that this system is in equilibrium. So whatever view is comfortable to you, you should be able to think in that term. But please make sure that you are quite clear about when you are thinking about external loads, internal means the reaction forces. So that idea should be clear before you actually attempt to write the equations of equilibrium, and then that basically will be the whole purpose of this unit. We will see in some very specialized systems which we will call say plane trusses and frames. We will use some special, still some more special techniques to solve them, but in general the story will be like this, that the equivalent resultant, the simplest resultant should be 0 if you consider both externally applied plus the reaction forces. And I think in a earlier segment I might have told, if I have not, then see this thing is, we had told that for equivalence there should be two tests, okay. That means you pick any point in space, any direction in space, in 3D space, and in that direction the pulling or the pushing effect should be same in two systems, if those two systems are equivalent. This is test number 1. Then test number 2 is you pick any point in space, and about that point the total turning effect or effort, okay, turning efforts due to all the forces should be same in system A and system B. If these two conditions are satisfied under system A, B, C and everything, so those systems will be called equivalent. So again repeating, any direction the pull and the pull or the push effect should be same. Similarly, any point you choose, about that the turning effect should be the same. Okay. And then that freedom of choosing the point direction and choosing the point is up to you, and it should be true for any point that you pick and any direction that you choose. So that's very important. And then under this, so if you apply that concept here, the same thing happens. If the system is in equilibrium, that means you pick any direction, the force should go to 0, and if you pick any point, the moment should vanish. Because if it happens about one direction, so you have, and then about at one point, if that happens, so by the equivalence statement, it should happen with all points and all directions. So that is another very strong concept which you should always use while thinking about equilibrium. So we will in next segment, so this is just the introduction to talk about what equilibrium is, but then we will see how to apply whatever we have learned in the previous segments, and we will go into some specialized systems as I told. See you in the next segment.